Okay. Welcome everyone to this fourth Industrial Transition Series webinar. Today we'll be talking about CCUS, carbon capture and storage, and we'll have first an introduction from the IETS Secretariat from Edina Svensson. And then a short presentation of a task related to CCS within the IETS, which is Net Zero Industrial Processes in a Circular Economy Framework, from Philipp Wolf-Zöllner. And then we'll have 3 project presentations. The first one will be a French project about the shock oxycombustion. And then we'll have 2 other projects. So the first one will be carbon capture and storage in action, actually, with the Yara project presented by Edina, Ringdal, Wickholm from Yara. And finally, the presentation of the ACCSESS project, aiming at providing access to cost-efficient, replicable, and safe, flexible CCUS from Kristin Jordal. So that's it for my part, and I leave the floor to Elin to start this webinar.
Thank you for that introduction, and welcome from me as well. So my name is Elin Svensson, and I represent the Secretariat of IETS, which stands for Industrial Energy Related Technologies and Systems. Sorry, I need to switch the slide as well. In IETS, we have 13 member countries, so it's an international collaboration. And beside the 13 member countries, we have also additional sponsor organizations from yet 3 other countries, and all of these represented by the flags here. The IETS is, as I already said, a technology collaboration program, short TCP, and the TCPs are unique global networks under the International Energy Agency that brings together governments, industries, and leading experts to support energy efficiency and decarbonization. In total, there are about 40 TCPs, but the IETS is the only one with a dedicated focus on industry. And the overall aim of IETS is to strengthen international cooperation on energy savings and greenhouse gas mitigation in industry across a broad range of sectors and from both a technology and a systems perspective. Our work is organized in tasks, and these tasks are collaborative research and knowledge sharing activities, each focusing on a specific topic. And at the moment, we have 8 active tasks covering both technology-oriented and system-oriented aspects of the industrial energy transition. And today's webinar is primarily connected to task 21 on net zero industrial processes, in which one of the subtasks is focused on carbon capture, and you will hear more about this very soon in the next presentation. However, I would also like to point out that carbon capture, utilization, and storage applied to biogenic sources is also covered in task 11, which includes work on technology pathways towards net zero and negative emission biorefineries. But as you see, overall, IETS covers a breadth of topics: membrane processes, digitalization, electrification, circular economy, energy resilience, drivers and barriers, and process integration. So, why should you participate in IETS work? As a participating organization, you get the opportunity to engage in international collaboration, to communicate and network directly with leading research groups. And this leads to various synergy effects and opens opportunities for knowledge transfer. You also get access to reports, workshops, and webinars that are not open to the public, or you get early access before they are published. So how do you contribute or participate in a task? Participation is based on task sharing, which means that you bring your already funded projects and contribute by actively participating in meetings, workshops, and other joint activities. So that means there are no calls or central funding, but participation is based on everyone's contributions of time and expertise, which potentially can be funded by national funding sources or other projects. So if you're interested in joining a task, you can contact the task managers directly, your country delegate, or us at the Secretariat. But to join a task, you have to belong to one of these member countries or become a sponsor organization. And we also welcome new member countries. On the IETS website, you can find more information about all of the tasks, events, publications, and contact details. A good way to stay updated is to subscribe to our newsletter, and then you will also get invitations to upcoming webinars in this series. With that, it's all from me. Don't hesitate to contact us if you have any questions or want to know more, and I hope you find today's webinar very interesting.
Thank you, Elin. And you can already go to the website to see our previous webinar on other task topics, so don't hesitate to go there. And Philipp, I leave the floor to you.
Thank you very much, Lucille. Yes, also a very warm welcome from my side. My name is Philipp Wolf-Zöllner, and our task manager of task 21, Simon Moser, is on a well-deserved vacation today, so that's why he asked me to give you a brief overview and information on our task 21, which is net zero industrial processes in a circular economy framework. I'm from the Technical University of Loeben, based in Austria, and I'm a senior researcher there in the field of carbon capture, utilization, and storage. So what is task 21? We came already along, had a long path already, starting in 2020 with the definition phase of task 21 to define this the structure of this task. And as you can see, we had 3 phases, and we are already in phase 3 since January 2025, where our phase is split up into 2 subtasks, so-called subtask 4, which is all around carbon dioxide capturing in the industry. So really they are focusing on carbon capture processes. And the second subtask we're currently working on is the facilitation of industrial symbiosis. The subtasks are split in a couple of activities. In both activities, always a strong focus on networking and webinars and workshops. That's how our task is being organized in having this strong networking focus. Right now, activity A is going to find an end very soon with a presentation that I will show you very soon. It's on all the national perspectives of carbon capture, utilization, and storage with CO2 management strategies, the national legal provisions and national legal views. Also on defining a second activity on the value chains and coming up with a detailed stakeholder database through questionnaires. And activity C, that's where I'm mainly working on, is the integration of the carbon dioxide capture in the industry, where we are really looking at on the technical side on the implementation of carbon capture unit in industry, how this is working out, how well it is working, and sharing information around the industry partners. You can see on the next slide our international partner structure that we have right now in the phase 3, with Austria having the task management and subtask management. We have the rice company of Sweden. We also have Australia on board now, Denmark, Germany, Italy, even Canada, Netherlands, Norway, and Portugal. Various universities and companies joining our task. And in Austria, we have a series of research affiliates that are working on this task. And as I said, I'm from Montana State or Technical University of Loeben. We are having a final activity workshop on Monday, June 8th, where you are welcome to join and register through this link. I'm pretty sure the slides will be shared afterwards where you can register. This workshop will be on the national legal provisions of carbon capture utilization and approaches to CO2 management strategies across countries, how this is going to look like, followed by a discussion session, providing you an opportunity for exchanging challenges, experiences, and opportunities across different national contexts. We had, as giving you an example, a workshop similar to this one with 60 participants in September 2024, 2 years ago, that I took care of with a couple sessions on presentations on real carbon capture processes, and then also carbon capture utilization presentations and carbon capture and storage presentations from Fraunhofer IGB, Technical University of Munich, from SINTEF, from WISE, where all this knowledge was being able to share that was built up during the last couple of years. And that's what we are focusing on right now in more detail. So we would really like to bring people together, discuss and talk about their problems, challenges, real life challenges that the engineers had during installation and startup of carbon capture units in the industry. And we're going to have on November 12th in the morning to have our Australian partners also available and participating another workshop, which is on carbon capture in the industry in cooperation with the IEA greenhouse gas section. And we're currently seeking for speakers there because we would like, as I said, to focus on actual projects and technical challenges during the implementation of carbon capture units in the industry and in the energy sectors like steel, cement, and so on. So if you are interested in that, being a possible speaker for this webinar, you're very welcome to get in contact with me or with the IETS management, which is Simon Moser. You can see our email addresses here on this slide, and you are happily invited to make a presentation there showing your actual challenges that you had in real life if you're interested. Yes, that's already everything from my side. Thank you very much.
Thank you. Thank you, Philipp. If you have any questions, don't hesitate to write those down in the chat. We'll have several Q&A sessions at the end of each presentation, and you can navigate through the presentation and the slides, and actually you can click on the links, so you can already register for the webinars and click on the email also if you want any more information. Thank you, Philipp, and we'll go to the first project presentation that is from Naldeo for the SHOCK project. And I will let, I think, Pauline, Plisson and Soizic take control of the presentation and start presenting the project.
Hello, good afternoon. Thrilled to be here and thanks for inviting us. So I'm Pauline Plisson, I'm an Innovation Director of Naldeo. The slides should shortly be appearing on the screen.
Soizic, can you take control of the presentation? Does it work?
Is it working?
Yeah, it's okay.
No, I think I still have the control. Okay, great. It's working now.
Working for
Thank you.
So you can go to the next slide. So just a quick few words on who is Naldeo. We are an independent engineering consulting company headquartered in France. We are specialized in climate solutions and covering a wide a spectrum of services from upstream feasibility studies, consulting, due diligence, all the way to construction services and the commissioning of plants. You can go to the next slide. So we are based in France, but we work in all regions of the world. Next slide. As regards carbon capture, which is the topic of the day, we are involved in some of the major projects, CCUS projects currently ongoing in France. One is called Go CO2, the other one is called Rhône CO2. The principle is pretty much the same. So the major industrial emitters in the area are going to put together to mutualize their CO2 emissions with individual capture units, but mutualized pipeline to transport CO2 all together to a port, a shipping facility, where new infrastructure is going to be built next to existing LNG terminals, liquefied natural gas terminals. And these terminals will be equipped with new infrastructure to liquefy CO2 in order to ship it, either for sequestration in the North Sea or for other usage, e-fuels and all kinds of new usages from CO2 that are appearing. Next slide. And another illustration of what we do in CCUS. This is a project that we carried out for a startup named Pure, who developed their own proprietary technology for CO2 capture, specific for low concentration flue gases with a low concentration of CO2. For example, gas turbines are typically an interesting source for this kind of technology, and they don't use amine, which is interesting in terms of environmental impact and energy needed for regeneration of the solvents. And we were their chosen engineering firm to design and build their first demonstrator that they are now using for performance proof. And now to the core topic of the day, a SHOCK project, where we are leading a consortium of about 15 partners. The goal of the project is to build a demonstrator, but the word demonstrator is sometimes misleading. It's more a first of a kind approach, because the size of the units, and we're going to show you pictures because it's actually a real unit that's now live and in operation and undergoing tests. It's a 3 megawatt unit, and we aim to, after the testing phase, to replicate and sell the same size, the 3 megawatt unit, to our future customers, which are going to be companies with industrial plants who need to decarbonize their steam production. The consortium is formed of the key partners, who are the 8 logos on the first part of the slide. So Naldeo is leading the consortium and coordinating the technical developments, but we do have partners who are all very important in the project, bringing their own expertise in the core of the technology. And we have observing members who represent future customers of the solution. And you can see with the logos that we have people from the agri-industry. We have companies from construction industry, companies from metals industry as well. So applications can be quite wide, and we have a variety of future customers who are showing interest in the solution. Soizic, do you want to take it over from here?
Yep, okay. Thank you, Pauline. So hello everyone, I'm Soizic and I work on the pre-design studies for the pilot, and now I'm working also on the preparation of the test campaign, which is imminent. Just a little disclaimer, my speaking English is kinda rusty, and I'm very aware of my Frenchy accent, but I will do my best to provide an interesting and understandable presentation. Pauline introduced the shock, but now let's move on more technical details. What is the shock? How do you make one? And how does it work? So it's based on the oxycombustion concept. The main idea is that instead of burning gas with air, like it's traditionally done in boilers, you do it in oxygen, meaning that in the off-gas you will mainly have CO2 and water, and theoretically you just have to get rid of the water to capture the CO2. But that's the theory, and that's fun, but we live in real life and not in theory. And we need a pilot to demonstrate how it works and to face the different challenges that comes from real life, like pollutants or making work the different technological bricks. So think of the shock as a Lego with different bricks. The first one of the most important, is a low NOx burner developed by our partner Fifth Pillar. Okay. Yes, I have a laser. The burner, which was specifically designed for the pilot in order to provide low NOx combustion with air and with oxygen. Then you have a combustion chamber, which works in temperatures that are identical to that of conventional boilers. This is made possible thanks to the FGR loop, so the fume gas recirculation, in order to play the role of the nitrogen, which is present in air in traditional combustion. But remember, we don't have it here because we want to make our combustion in almost pure oxygen. Therefore, the combustion with only oxygen is much more efficient. We might reach way too high temperatures, so we use the recirculation loop in order to maintain the temperature as admissible values. Next brick is a condenser. So as I said, we want to get rid of the water, and in the end we have only pure CO2. Theoretically, in fact, we still have some remaining O2, nitrogen, pollutants like NOx. We'll talk about them later. We send all of this off gas to the liquefaction unit in order to capture most of the CO2 that is present in the off gas and to liquefy it before transportation or usage. On the low right part of the slide, you can see several expected performance indicators. The values are based on our calculation during the pre-design studies. We do really hope that we will reach them, hopefully maybe outreach them, but to validate them, we need a pilot. Because in fact, all of those technological bricks are kind of mature today, but the fact that we use them together is kind of new, and we need to make sure that everything works in a whole system. So the pilot, it is supposed to work at 3 megawatts and is based in Villars-Saint-Paul, a chemical platform based in Oise in France. It's like 45 minutes from Paris. You can see several pictures, actual pictures, because the pilot has already been installed and is almost ready for the test campaign, which is kind of imminent because we are supposed to start the parametric test in June, which is like tomorrow. And the commissioning is, pre-commissioning is almost done. Commissioning is coming in a few days. And the test campaign should run until the end of the year. So the test campaign is divided, roughly divided into 2 main parts. So first of all, a parametric test campaign. The idea is to test the sensitivity of our system more specifically the different performance indicators that were shown on the previous slide, in order to see how these parameters influence our performance. For example, how changing the quality of the oxygen will enable us to reach the capture rate of CO2, the electrical consumption, and so on. Then we have a second part of for the test campaign, which is a long-term load monitoring test. Here we kind of fix almost of the parameter operating conditions. We just let the load live its life in order to follow the demand of the site. Because the point is to provide a system that will work on real industrial conditions, and we want to see how the system will answer to those real constraints. And since the aim in the end is to provide a real commercial solution in order to decarbonize industry, we want to use the pilot to understand, to get as much data as possible, to understand how we can face the challenges surrounding our system. More specifically, for example, the CO2 specification, because if we want to integrate the shock to a global CCUS ecosystem, we need to be able to provide really high quality CO2. Particularly, for example, if we want to reach the food industry, we have to answer to the food safety standard EGA. But also, if we want to send the CO2 to storage, for example, in Northern Lights, we need to follow the requirements for the transportation, which imply a quality for CO2 which is almost equal to that of the food safety standard. Then another of the main challenges of the stock is the NOx. Based on experiment on oxycombustion and so on. So we get rid of most of the nitrogen which is present in the air, since we burn in oxygen. But as I said before, we are in real life, not in theory, and the oxygen is never pure at 100%. You can still have some traces or even several percentage, like 1 to 7% of nitrogen within the oxygen. You can also have nitrogen naturally present in the gas, which means that in the end you will face NOx problems. So that's why, first of all, the burner was designed to provide really ultra-low NOx combustion. And one of the aims of the pilot is to demonstrate that we reach the low NOx emissions. To do so, there will be continuous monitoring along all of the demonstrator and specific campaign tests with more specific instrumentation. And in the end, as I said, the objective is to get data from our 3 megawatt pilot, but also to provide systems that can work for industrial context. Today, among our work, we have already started some studies on real industrial cases, which imply different constraints than those we have on the Villers sample site. For example, you can have various ecosystems. By that I mean that your oxygen can have a different origin, meaning that its quality will vary, implying changes on the NOx issue you can have, on the CO2 capture rate, and so on. Also, what will become of the CO2? Will you use it on site? Will you need to transport it, to store it? And then you have the on-site constraints, which can come from your steam consumption. Do you have specific seasonality, or is it stable all along the year? Do you have enough land available? If I just come back for a few seconds here, you can see that the liquefaction module takes some place. The shock system does not require only to have place for the boiler in a specific room. You also need to have some land outside in order to set the liquefaction module, the CO2 storage module, and the oxygen storage module. Then you also have constraints that are relative to the shock system itself, more specifically with the operating range relative to the rated power. For example, the boiler works from 25 to 100% of its full capacity, meaning if you, for example, if you have a 10 megawatt boiler, it cannot deliver steam under the limit of 2.5 megawatts. We have a similar constraint for this liquefaction unit, which is even more drastic because it goes from 50 to 100%. That means that to respond to specific site needs, we need to adapt the system, adjust the number of each unit. Still think of the Lego analogy I made earlier. You can, for example, multiply some of the bricks. So in the end, we can work on very specific studies in order to adapt our system to specific situation. And I have a rough conclusion, but I will stop here and I will be happy to take some questions if there are some.
Wait to see if there are some questions coming. In the meantime, I have some. So yeah, we'll see that the input of oxygen and the output of CO2 usage are two parameters. So have you already targeted some industrial sectors? Is it mainly the agri-food sector, because we see that they are involved in the project? So what are the other maybe region when you can install the the shock project, or other application also that can be benefited from?
Yes, okay. So yes, as we said, the food industry is pretty much interested, more especially if we can reach the food safety standard. But there are other scenarios that we studied that are kind of interesting. For example, there are the ESAF sector could be interested by it because the shock system needs some oxygen to work, and it provides the CO2, which is used in the production of ESAF.
Sustainable aviation fuel for the...
Yes, yes, sorry. While during the process for the ESAF, you also have oxygen, which is a co-product. You produce it, but you don't need it. So it's one of the scenarios in which the shock is an interesting Swiss Army knife, because it really goes well into the process to provide the steam and CO2 that are needed in the process, while using the oxygen that is already available on the industrial site. Also, it can be interested for every other process which requires steam and that needs to decarbonize. I'm thinking of greater size industrial sites which are which needs to IETS. Sorry for my French. So the carbon tax, which are submitted to the carbon tax, and who needs to send the CO2 to storage in order to avoid the carbon tax.
So if they have already they plan to use some carbon storage facilities and pipes, also using the shock boiler to provide them with decarbonized steam can be competitive compared to other decarbonized boiler solution.
Yes. So as I said in the last slide, so in our specific studies, so we provide several deliverables, and one of them being the global cost evaluation, CAPEX, OPEX. And we do know that this is a very important parameter for the industrial people who will have to decide between different technologies. It does depend. We do not have today a single answer. We have sites in which it's really competitive, it's interesting, and we have others for which it's more complex due to the cost of oxygen. And it also really depends of what will happen to the CO2 if you want to balance the global cost. So that's why you need very. So that's why I insisted on the fact that every industrial context is specific and requires specific studies.
And among the industrial partners of the project, are there already? They seem to be interested in the solution. Are there already projects in? Are they already talking about using the solution if the tests are successful?
Yes, well, maybe I can take this one if you want. But yes, we have on the origin of the consortium, you can see some of the names are very familiar because I think everybody knows Coca-Cola. And well, they had a clear interest in joining the consortium at the very beginning because they need to buy and source CO2 for their plants. And this causes both economic with prices going up and environmental issues. And yes, well, not only them, but all the names here joined the consortium with a clear intention to adopt the technology on their sites. Which one is going to be the first, I cannot tell as of today, but they are all looking at precise locations and feasibility aspects and budgeting processes and so on.
Okay.
But but it's also important to tell for the people here listening to us that we are also discussing with other counterparts who are potentially interested in adopting the solution. Not only in Europe, we are talking to people everywhere, and don't hesitate to contact us for a detailed assessment of whether it's relevant for your site or not, and entering into a pre-feasibility review.
Thank you very much. I don't see other questions. Oh yeah, a question. I'm not sure if it was mentioned, but would you see this being potentially viable for retrofitting onto older boilers or gas turbines? Yeah, it's interesting.
So, well, Soizic, correct me if I'm wrong. Retrofitting older boilers, yes, this is definitely a use case we want to address. Gas turbines, that would imply a different design. So we are not excluding that, but it's not directly applicable with exactly the same technology.
Okay.
So that's not something we have in mind for the at least short or medium term.
Thank you very much. I think that's all for the question part. Don't hesitate to reach out and see how the tests are going to run in the coming months. So good luck for that, and thank you,
Thank you.
for the presentation.
Thank you.
And so for the next presentation, we are going to talk about the CCS at Yara.
Yes, hello. My name is Edina Ringdal Wickholm. I work at Yara, and I just remembered that I have forgotten to have the first slide where you tell about Yara, but I will do it regardless. So Yara is a fertilizer company. Nitrogen is our business, and we primarily use it in fertilizers. But we also use it in the production of industrial products like AdBlue, for instance, which is very important for our heavy transportation here in Europe. I'm going to talk to you about our CCS project at the site we have in Sluiskil in the Netherlands. It's just almost across the border to Belgium, but on the Dutch coast. Now, this site is actually Europe's largest fertilizer production site. It produces 340,000 tons of hydrogen, and we turn that hydrogen into ammonia, and we use it to produce 3.5 million tons of fertilizer and almost 1.5 million tons of these industrial products that I was talking about. Now, fertilizer production it's a very energy intensive industry. So we use about 19.5 terawatt hours of natural gas at the site in Sluiskil, but we are the single largest user of natural gas in Europe because we need it to produce our fertilizers. There's about 750 people working at the plant in Sluiskil, and we have continuously invested in that site over the last decade. So even before we're doing the CCS project, we've already been able to reduce the GHG emissions by 65% since 1990. And we also export quite a lot of what we produce out of the EEA area, the EU and EEA area. And the products that we produce, they end up feeding 40 million people. And we are also, through the AdBlue, we are removing 700,000 kilotons of NOx, nitric acid. And what are we doing now? Well, we see that we need to cut our emissions even more. We will actually need to continue to produce using carbon at Sluiskil. I will get back to that because we actually need quite a bit of CO2. But as part of our decarbonization roadmap, we want to cut emissions more. And another very important driver is basically cost abatement. So we want to reduce or avoid costs on CO2 emissions. And we believe that there is also a business opportunity here. With this project, we will be able to deliver quite large volumes of low carbon fertilizers and low carbon AdBlue. And just so that you can see the numbers, we are planning to, or we will be capturing and permanently storing up to 800,000 tons of CO2 per year. We have an agreement with Northern Lights, who's our transportation and storage partner. That agreement lasts for 15 years, and in those years we will then have permanently stored around 12 million tons of CO2. The investment was actually quite well compared to the numbers. It's a reasonable investment. I will get back to why that is the case for this project. It's quite a fast project, so I will show you the timeline afterwards. But since we started construction in December of 23, and then we are in the very final stages of getting the project ready to, it will officially open on September 7th this year. Just to see how we got here, so we have, as part really of our ongoing operations, we do a lot of feasibility studies on how we can reduce emissions. And for Sluiskil, Yara Sluiskil, we identified CCS as a possible option. There are several reasons. One is that we need to continue producing CO2 there. So purely electrification step wasn't really what we were looking for in the short to medium term. Also, the volumes at this plant are so large that you get the cost per ton that you want to transport and permanently store down, which is also important. So we signed a letter of intent with Northern Lights in August of 22. Then we signed a agreement which was our final investment decision in November of 23. We did that even though we were missing an important part, because at that time there was no binding framework for transporting CO2 across borders, and we needed to transport our CO2 from the Netherlands, where we capture it, to outside the Norwegian coast, where it is permanently stored. But luckily, we also got an agreement between the Dutch and Norwegian governments, so that we are able to do that. And then we started construction really late December 23, but throughout this period. And we will enter into operations now, pretty much, and store for, or the first agreement at least is for 15 years. So I've been talking about that we actually need some CO2, because we get when you produce ammonia, which we do, you get CO2 as a byproduct. So you get it as a process gas instead of, like we've seen in other examples, of flue gas, which can have quite low CO2 concentration. Our CO2 is food grade when it comes from the because it's a process gas. So we can either use it in urea, which is a type of fertilizer that has CO2 in the fertilizer. We can also use it directly for food industry. So if you have a cold bear these days, then the bubbles might come from one of our sites in Europe. And you can also use the CO2 directly into greenhouses, as we do in the surrounding area of Sluiskil, because you also need CO2 to make plants grow. But we still had leftover CO2 that was emitted. And that's the part that we are now able to capture and permanently store. And that's around 800,000 tons, as I said, which equals 5% of the annual CO2 emissions from the Dutch chemical industry. So it's significant. Just to go through the different parts of our capture project. So our CO2 comes as a process gas. So for us, it's quite easy to capture it. That is something that I believe sets us apart from a lot of other capture and storage projects, because if you're starting with CO2 in flue gas, then just capturing and not to least to mention trying to purify the CO2 is quite costly and quite difficult. For us, that part, which is difficult for a lot of other projects, is actually easy. So we're lucky in that regard, but we still, of course, we need to do some investments. We need to liquefy the captured CO2. We need to dry it. We need to store it at site intermediary until we can have ships come and pick it up. And then we needed to have local pipes from where we capture the CO2 to where we can load it into the ships from Northern Lights. And of course, we needed to build our quay a bit better and different to be able to, in addition to load ammonia and fertilizers as we do today, we also need to load CO2. But still, compared to a lot of other capture projects, we are lucky in that the amount of investments we need to start are limited compared to others. Now we have got almost everything in place. There will be 2 dedicated ships from Northern Lights. They will each come once a week to pick up the CO2 that we, in the meantime, will store in one of 7 quite large storage tanks. Each of them is the size of an airplane, so they're massive. And after that, Northern Lights will permanently store them 2.6 kilometers below the Norwegian seabed. So it's a very safe and permanent storage site. Just to see those different parts at the actual site. Now I need to find my laser. There it was. So this is the existing ammonia factory. This is where we will also do the carbon capture. So we capture the process gas. Just next to it, we'll go in pipes to the CO2 liquefaction plant. It's actually the largest CO2 liquefaction plant, sorry, in the world. So that's quite impressive, and that's already built. And then you have the 7 quite massive storage tanks just quite close to the liquefaction plant because you want to have short distance. And then you go through a new pipe rack all the way here and then down to the docks where we will load the CO2 onto the ships from Northern Lights. As you can see here, you have the tanks. They now have a bit of scaffolding around them, but I'm hoping that that will come down pretty soon. And we are, as I mentioned, officially opening the site on September 7th. And I just wanted to share a short video just so that you can see that we were there for, I think it was about a month ago, so you can see what it looks like now. Except I can't get it to play. There. Yeah, that was 1 month ago. We were there and we're very happy that it didn't rain as it had been doing the 3 days before the shooting of the video. So, and the ship that you saw, that was the Northern Phoenix, one of the 2 ships that will be going in shuttle transport between Øygarden in Norway and Sluiskil in the Netherlands. There will also be a second ship, which is called the, no, now I can't remember it, something with a P as well, and that will has just been finished in being built and will call on us, I think, in about a month's time to make its first visit to Sluiskil before it starts transporting the Northern Purpose. Sorry, the Northern Purpose and Northern Phoenix will be the 2 ships. And that was really what I wanted to share, but happy to take all of your questions. I saw that some had come in the chat already. Should we just look at them together?
Exactly, we can do that. Thank you very much for the presentation of the project, which seems to be really exciting to be beginning and starting, finally finishing in September. So the first question was how will this project affect the EU Yara value chain once the CO2 captured at MDEA is being stored underground and not made available for Yara production?
Very good question. So actually, we will not be permanently storing all of the captured CO2. What goes into the urea production today will continue to go into the urea production. So this is for the parts that we were capturing, because we're capturing more than we are using to produce the urea. So it's a very good question, but it will not affect the production at that site.
Okay, another question was, do you have any information public or that can be shared about cost, capacity, lessons learned, operational use from your on-site CO2 storage, intermediate storage?
From our tanks, let's see, how much can we share? Well, they are being they will be part of permanent operations from this time, really, or a few weeks forward. So it's limited how much experience we have in using them. One thing that we discovered when we were, because I'm sure a lot of you know, because we are doing this in an existing industrial site, which sometimes entails a lot of issues. One of the things we actually discovered was that by laying our tanks flat instead of having them upright, we were able to reduce OPEX costs, because it's a lot easier to do maintenance and do everything you need to do if you can lay them down instead of standing them up. So that's at least one lesson that I can share. So if you have, and of course you have to make sure, because it can affect the footprint. But for if you have the possibility, then OPEX costs will be reduced. So free lesson.
Okay. Another question: is there a limit, at least in theory, on the maximum capacity of CO2 in the seabed?
I will. I'm not the storage expert, but we have been quite diligent in checking how much this tool can be used, and what we get from the storage experts, for instance, Northern Lights, which is our partners, is that there is more available storage capacity than there ever will be CO2 to put into it, apparently. So I can't, I don't know this, but I think we are very, very, very far away from hitting any kind of limits on the storage capacity. I think what we've discovered is more, it's difficult to get the business cases going to have, like, I know that Northern Lights have been very reliant on the capex or investments that the Norwegian government started them off with. So we need to get to a place where it's possible to have a bit more to make these business cases make sense, both for the storage operator but also for the they call us the emitters, but I like to think of us as CO2 providers. So that's really, I think that's a more pressing issue than the availability of storage capacity. It's more, is it possible for us to utilize that storage capacity?
And so I think the next question is, out of 100 of your CO2 emissions produced on the site, how much are stored or used as another product? Are there still leftover CO2 emissions?
There will be some leftover CO2 emissions, primarily from combustion, which we still have, where we will have emissions. But I think total with this, we are talking about a pretty clean site. So we had 65% of our emissions already reduced, and then this will take 25% of everything else. So we're getting there, but there will be some emissions left, and also, of course, because we need to use some carbon.
Okay. I think that's all, but maybe I had a last question for you. So you constructed the whole site to use and to send your CO2 emissions to Northern Lights. Now that you have the existing infrastructure for CCS, are other industrial sites, maybe in Sluiskil, interesting in using those? Can they use those? Are you going to reproduce maybe this model on other Yara industries elsewhere?
Also very good questions. So I think for fertilizer plants, or for ammonia producing fertilizer plants, which is where it's easy to catch the emissions, this is a technically very viable path and easy to reproduce, or easy, in so far as a large industrial project can be easy to reproduce. What we see that what's difficult is getting the business case to work, because there are investments that you need to take. And again, when you have such a large project as Sluiskil, it's possible to get down to a viable price per ton removed. It's more difficult at smaller sites, and this is the largest site in Europe. So there's no other sites that are large enough in our portfolio, at least. And there are a lot of plans for storage. Not all of them have materialized, so we're not at the point yet where we can say that there is any kind of sort of healthy competition amongst storage operators. So that's something that needs to come online. Infrastructure is sorely lacking now. So this is now you have 2 ships serving one site, going shuttle, and that's okay when we're just at the beginning of CCS, using CCS for industrial decarbonization, but I don't think it's really feasible going forward. So we need to think CCS hubs. We need to collect our CO2 together, and pipelines would be perfect. I know that's very costly as well. Maybe it's possible to see if that could be somewhere where governments could step in and reduce the burden. And we need to, that's maybe the most important thing, we need to make sure that the products that we produce using CCS, so our low carbon fertilizers, for instance, and low carbon AdBlue, that that it has a market, that people want to pay for it. And that's also something we're working on.
I think that's all for the questions. Thank you very much for your presentation and for being one of the first users of the Northern Lights. And I think we're going to the last project presentation of this webinar. Thank you again.
Thank you so much.
Should I taken control now?
Yes,
I think
Kristin,
that works. Let me see if I can change my slides also. There we are. So thank you so much, Edina, for a super interesting presentation. It was also very interesting to hear about the SHOCK project, but I'm so happy to see that you're actually doing this for real. So I'm going to go back to research and a little bit of piloting on CO2 capture in the ACCSESS project. Just run to the next slide immediately so that you can see what this is. So this is an EU-funded innovation action that one of the last Horizon 2020 projects probably. We have a duration from 2021 until 2026. We have we're in 2026 now. This is an old slide, the first one. I'm sorry about that, but because we had the project extended a bit. We're coordinators from SINTEF in Norway. I'm the project coordinator. I have a very good team around me. This is not something one does on one's own. We have a budget of 90 million euros and an EU funding of this of 50 million euros. And this project has 3 parts, where the main part or the blue part is the biggest one with CO2 capture, where we have demos on both CO2 capture and CO2 use in terms of mineralization with industrial relevance, and also looked a lot on the integration of CO2 capture in different industrial sectors. We have what's the green part is about the chains, the CCS chains, how to develop these, how to improve first chains, looking at continental Europe and the Baltic area and going to North Sea for CO2 transport. Of course, it's desktop work only, not what Yara are doing. Then there's also a societal beat about engaging and informing stakeholders about CCUS in general. And we have also had a specific task on sustainable cities and how to CCS in that context. A little bit about CO2 capture integration in industries. We have looked at 4 different industrial sectors in this project. It's pulp and paper. We're trying to illustrate that with the hexagons there. It's a pulp and paper, cement, waste to energy, and biorefineries. We didn't have a very good logo for that, so it's just a bit of biomass there. And we have looked both at heat and mass integration as well as investigations of redesign in some cases of industrial plants, and looked at what's the cost reduction potential if you go beyond, say, the first implementation of CO2 capture without so much heat integration and so on. So basically, what it's about that you have raw materials, fuel, and power entering the industry and products leaving the industry. I mean, that's the main job of an industry, to produce products they can sell. Flue gases go to a CO2 capture plant where you have, I'll see, I use the laser, where we have CO2 lean flue gas leaving when it's been captured. CO2 capture always requires energy in one way or another. So we have waste heat sometimes in industries in different quantities and qualities, and can send CO2 to transport and storage. We need to add some power and sometimes also some heat. And all this has been investigated. And I'm just going to show you, I can't change slides there. This is all the partners that have been involved here, including Chalmers actually, and Elin, who is the secretary of in the Secretariat of IETS, and a lot of other research partners and industrial partners. I will give you a couple of examples of reports that are already available and open, and there will be the links to some websites also in the end of the presentation. So we have one report on capture-ready waste-to-energy plants. It was looking at analyzing different types of data from existing waste-to-energy plants, looking at the techno-economic case studies, what's the sensitivity of the solvent degradation compared to gas impurities, for instance. Also looking at the EU regulations for best available reference technologies and so on, really taking the overall picture on this. There have been 3 reports that are open on CO2 capture integration in pulp and paper. This is one of them. Also here, Chalmers and Elin have contributed. This is one that shows techno-economic analysis, both for a kraft pulp mill and I think it was also a waste paper mill, one in Sweden and one in Belgium. So those are some examples for what we did on capture. We have also looked at CCS chains in different ways. We have taken multiple perspectives around the same type of industries and products they produce. So again, we're starting with we have the industry, it produces products, sells them, makes money. A lot of industries use fossil resources, oil, gas, limestone in the case of cement. If we capture the CO2 and storage, then we can reduce the climate impact and reduce the fossil emissions. We'll never get completely to zero, but can get to at least 90%. If we use biomass that takes up CO2 from the atmosphere in these processes, we will have a process where we actually net remove CO2 from the atmosphere when we do CCS. So all the industry sectors we have looked at in the process has some, is a varying capability, but some capability to also remove CO2 from the atmosphere. And then we also had a pilot investigating mineralization with different alkaline wastes. And there were also value chain studies of products. What if you capture CO2 from the industry, what is the cost of the end product, looking both at transport, housing, disposable diapers, pulp, and a railway. And for the chain analysis with the transport of CO2, there was quite a lot of work has been done. Not everything is published yet, but there have been technical economic analysis and life cycle assessment for reference pioneering chains in access. From cement in Germany, transport to Wilhelmshaven, cement in Poland, transport to Stettin, a pulp mill in Sweden with access to port. You can see the pink one up there. And more advanced chain and waste to energy in Switzerland. And all this, there have been also more advanced chains in geographic migration, looking at different geographic areas that has been investigated. The synthesis of those results are ongoing, but we already have a report out since a couple of years with blueprint design for, say, early CCS chains or CCUS chains. Again, you can see the partners that participated in the studies at the bottom here. And then a couple of more examples of open results that were more, say, of societal nature. Was that Fraunhofer, who social scientists themselves, developed a report where they described some cases, what they call neutral solutions packages, try to describe CCS or CCU related cases for the laymen, I think is the word, people who are non-experts. And with the focus on, okay, how can this fit in a city context? I'm just putting in one picture to tell you that one of the things they did was that they interviewed Celsio, the waste to energy plant in Norway that is building a CO2 capture facility right now. And there's basically a knowledge dump from Celsio about a lot of lessons learned from when they developed their capture project. And there's also a handbook available, what they call about transforming municipalities and how cities can incorporate CCS or CCUS in their climate action plans, which is, there are lots of cities that have plans for reducing emissions. They have climate plans, and not all of them are aware of CCS and how they, for instance, can support CO2 capture and waste to energy. They can have public procurement where you would want to buy low carbon products and so on. And then last example about some results is that there was a couple of last examples here that there are a newspaper sentiment analysis was made also by Fraunhofer, where they went through using AI and automated methods, went through a lot of different newspapers. It's just a summary of the results here. I won't talk about it in detail, but basically what was an eye-opening for me is that newspapers tend to write more negative than positive articles about CCS. So maybe those of us who work with CCS have a bit of a job to do there. Then there was something called the Value Chain Transition Fund that was developed by Chalmers, which is, it's a concept so far, but the concept is about certifying that the cost increase for a low carbon product, which could be the fertilizer or AdBlue from Yara, for instance, that cost increase, the premium that is paid actually is returned to the company that did the investment for decarbonization, and it doesn't get stuck along the way in the middle hands. It's still just a concept, but it's quite interesting thought, I would say, to actually support the implementation of CCS. There, let me see. Now I'm going to talk a little bit about the CO2 capture piloting and that we did in ACCSESS. And before I do that, I'm just going to show 4 points on the map. Technology Center Mongstad, which is actually quite close to the Northern Lights storage site where Yara is sending the CO2 soon. We have Oslo with the CO2 capture plant in Norway in building. And we have the Stora Enso pulp mill in Sweden, and there's a cement kiln in Gorazde in Poland by Heidelberg Materials. Okay, I need to stop the laser pointer every time I change my slide. So there's a lot of animations on this slide, so hold on. We had a CO2 capture pilot test program with the CO2 solutions by Saipem technology. It's not an amine. It's potassium carbonate with the addition of an enzyme, which is a synthetic version of the enzyme we have in our lungs, that makes it easier to take up and release CO2 from the solvent. So when we started the project, Celsio had a containerized CO2 capture pilot on site in Norway, where they had tested a couple of different solvents. This was available, but they didn't need it anymore. So what we did in the project, what Saipem did, was to redesign and reconstruct this pilot for operation with their technology. And then it operated at Celsio in the summer of 2022. At the same time in Poland, two SMEs, ProSpin and ProCeller, designed a rotary packed bed absorber technology. This could be a presentation of its own in itself, but it's about replacing the high absorber tower with a rotating packed bed, which makes the technology much more compact. You need less solvent inventory. And also you don't need that very, very high tower. This one was built in 2021 and early 2022. Both of these were shipped to early 2023, I should say. Both of these were shipped to Technology Center Mongstad in Norway, put in operation together. It worked flawlessly with a rotary packed bed absorber, and they also ran with a normal absorber column as a reference. After that, we have had two different test campaigns at site, both at the Skutskär kraft pulp mill in Sweden and the Gorazde cement kiln in Poland. What is interesting, at least if you're a researcher, is that the operation went really, really well with the solvent at Celsio. It went well at TCM, and it went well at the Gorazde cement kiln, and it went less well at the Skutskär kraft pulp mill in Sweden. And what's also interesting is that we can present this and talk about this in public. We have written a paper together with Saipem. Elin is actually also one of the co-authors here. So it's Saipem, Stora Enso, SINTEF, and Chalmers. written what's called a perspective paper to present a little bit about the potential for CO2 capture from pulp and paper, how this could contribute to net carbon dioxide removal. You remember when you capture CO2 from biomass and you store it, it's actually taking CO2 out of the atmosphere. And the potential challenges when you have an alkaline solvent. So what happened at Stora Enso was that there was a lot of foaming in solvent, there was fouling, and this was preventing stable capture operation and preventing good performance of the solvent. This was tested with 2 different flue gases from the recovery boiler in Skutskär, where the recovery boilers had different operating principles. And there was we had a task force that really went through the flue gas beyond what you need to report according to the authorities and looked at what could there be, and several critical flue gas impurities were identified that could react with or interfere with the alkaline capture process. And we sit back with a hypothesis that there may be trace amounts of unburnt particles and other components that are not removed with the current flue gas cleaning steps. And there's also a reducing atmosphere in the boilers, maybe not full oxidation of everything, as we say, unburnt particles. So we sit back with several questions still. Is this a general issue of pulp and paper? Is it site specific? We don't know. But as a researcher, I can say that more research is needed. There is a big potential for carbon dioxide removal from pulp and paper. There's about the potential is about 50 million tons per year in Europe alone, which is quite significant. And this is from existing biomass, existing point sources. But you also need, of course, a mark for carbon dioxide removal certificates, as biogenic CO2 is not on the EU ETS. So here are some links to more access results. We have our community on Esnaut where we put everything on reports and everything. There's also the EU official website where all EU projects get their public results. We have our own website. We have about 20 peer-reviewed publications so far. A couple more are coming. And yes, one final thing. Next week in June, in Brussels, you can also participate online. We are having a final open event together with 2 other projects, CCUS Innovation and Core EU, and also what's used to be known as ZEP, the Zero Emission Platform, now Carbon Management Europe, which is a member organization that is an official advisor to the Commission on CCS. We're organizing an event called Making From Innovation to FID, Making CCUS Bankable. And it's still possible to register if you want to participate online. I think it can be a very interesting day. It's actually, I think, 4 hours or something, so it's not a full day. And the link is also then in the slides I'm going to send you. So that's all I have to say. This is the consortium we've been working with at Access. We thank the European Union for our money, and yeah, that's it. Thank you for listening.
Thank you very much for the presentation. So don't hesitate to write your question on the chat. In the meantime, I think I have a few questions. So for the at the end of the Access project, do you intend to reach out to some of the cities or projects where you identified that it can be an interesting CCS project? Like you pointed out several cities. Are they already inside the Access project, or do you plan to reach out to them?
It's a very good question. We didn't have cities as members, but we have talked to several cities, and we also recently from SINTEF concluded a project together with the city of Trondheim, where we are located, together with a private waste to energy plant, and try to investigate how can the city facilitate for the operator. Of course, I mean, the operator still needs money, but there was like a panel with citizens that were invited to come with opinions. It was a very well structured activity with sort of where they got to give their opinions on what would they see as a fair and just way of introducing CCS or CO2 capture at the waste to energy plant in Trondheim? Very, very interesting process.
Okay, and I think I have just a comment maybe on the social acceptance part. I'm aware of a project in France that is a massive project working on industry decarbonization, and they are currently investigating the social acceptance of CCS. So it's the Sesame project from the Spleen project, but yeah, that was just a comment because that might be one of the issues because even if cities want to invest in that, will their citizens follow them?
Yeah, I think it's a very, very good question. We must not, as engineers, just get stuck on, yeah, this is super good, we can cut emissions, because we need to explain what it is, because it's going to cost money one way or the other. And why should we spend money on it? And but I think also talk about how much emission cuts we get for the amount of money that would be spent is also very interesting, because I think CCS comes out quite well there.
Yeah. And I have maybe another question. I think that a lot of industrials want to invest in industry decarbonization, but they have real issues currently on long time visibility. Have you investigated the fact that maybe they can't invest for projects in 10 years to come, or yeah?
I think that's one of the problems that we identified also in the paper that I showed there, that when we talked to Stora Enso, and they say that, I mean, even if, I mean, they need predictability for 30 to 40 years if they're going to invest in CO2 capture. We had Yara had 15 years, but Stora Enso said that we invest for 30 to 40 years, sorry. And it's so expensive for them to build CO2 capture when there is not a market ready to buy huge amounts of carbon removal certificates when they're not on the ETS. So I think, I mean, that's one of the things we're going to discuss in the event next week, right? And it's very interesting when we have banks also participating and in that discussion next week. The funding and the financing of CCS, that's important.
Okay, and I see that we have a question in the chat. So for your CCUS value chain analysis with centralized storage at the Aurora complex, as more sites begin capturing CO2 and injecting there, could injection rate limits become a bottleneck? Specifically, did your analysis account for geophysical injection limits and site expansion timelines, such as drilling additional wells and so on?
It's a very, very good question. I think no investigations went further to the Northern Lights hub. It's not, we didn't have a budget for also doing detailed storage, but it's a very, very good question. But yeah, it's all this about the chicken and the egg here, right? How many storage sites you build out and how much CO2 you can capture and to be able to store.
You can discuss that point on the workshop next week, so you are very welcome to register.
Yes.
I think that's all for the questions, and we'll be on time for the end of this webinar. Thank you very, very much for all of your presentations. We have seen very interesting projects. Don't hesitate to go to the IETS website when you can find the 3 other webinars that were done with also very interesting projects on several subjects. Thank you everyone for being here, and have a nice day.
Thank you.
And thank you for all the presenters and the very interesting presentation. Thank you.